Hello everyone, I'm Miss Priyanka Goswami and in today's video I'll discuss about flow of fluid. So in today's video I'll start with a brief introduction of flow of fluid followed by fluid static, fluid dynamic and Reynolds number. So moving toward the introduction. So fluid is a substance that continuously flow under an applied shear stress. So fluid include liquid and gas. So we can define fluid flow as the flow of substance that do not permanently resist distortion. Fluid flow are of two types. Those are fluid static and fluid dynamic. So fluid static is defined as the study of fluid at rest. However, fluid dynamic is defined as the study of fluid in motion. So let's move toward the fluid static. Now let's take an example. Consider a column of liquid with two openings which are provided at the wall of the vessel at different height. Say for two openings are 0.1 and 0.2 and the height is h1 and h2 respectively. Now as the pressure exerted at the different height are different, so the rate of flow through this opening are different. Now consider the pressure P is acting on the surface of the fluid and the column is maintained at constant pressure. Now we'll determine the pressure difference at these two particular points. So we can write force acting on liquid at point 1 equal to force on surface plus force exerted by the liquid above point 1. So substituting this force with pressure into area of cross section in this equation, we can write it as pressure at point 1 into area equal to pressure into area plus mass into acceleration. So we have written mass because water layer above point 1 have some density. So we have written mass into acceleration. Now again modifying the equation, we can write it as P1S equal to PSS plus volume into density into acceleration due to gravity. As we know, mass is equal to volume into density, so we have replaced it. Now again replacing volume with height into area, we can write P1S equal to PSS plus height into area into density into acceleration due to gravity. So we can write it as P1S equal to PSS plus H1S rho G. Now as we can see, S is common in both the sides, so we can cancel S and we can write it as P1 is equal to PS plus H1S rho G, which is the pressure at point 1. Similarly, we can find pressure at point 2, which will get P2 is equal to PS plus H2S rho G. So now we can find the pressure difference between 2 points. So we can find it by substituting the 2 points, that is P2 and P1. So substituting P2 minus P1, ultimately final result will get delta P is equal to delta H rho G. Delta P is the pressure difference. Now moving toward the fluid dynamic. Now as I said, fluid dynamic deal with the study of fluid in motion. So this knowledge is important for pharmacists working in manufacturing dosage forms such as liquid, gel, ointments, cream, which will change their flow behavior when exposed to different stress conditions. So when we manufacture this product, there are different processes like mixing, filling. So in that stress condition, if the behavior changes, then it affects its manufacturing process. So we need to identify the flow. Next, in handling of drug for administration, for example, from syringe, if we administer some sterile dosage form, then at that time, if the flow behavior change, then it should be not patient compliance. So we need to identify the flow. So fluid dynamic is of two types. Those are fluid laminar flow and turbulent flow. Now as we can see in this figure, the first figure, as we can see, when the fluid flow in a pipe sequentially and there is no exchange of the fluid particle from one layer to other, then it is known as laminar, as we can see in the first one. Similarly in the second one, as we can see, there is no sequence in the layer, so it is known as turbulent flow. So whether the fluid is turbulent or laminar, we can identify it with Reynolds number. And Reynolds number basically have no units. So Reynolds number is affected by 4 factors. Those are diameter of pipe, average velocity, density of liquid, viscosity of the fluid. So these 4 factors are combined in one way as Reynolds number, and we can write Reynolds number as R is equal to D, which is diameter, mu, which is average velocity, rho, which is density of the liquid, divided by viscosity. So which is equal to initial force by viscous force. So initial force are due to the mass and the velocity of the fluid particle trying to diffuse. However, viscous force is the frictional force due to the viscosity of the fluid, which make the motion of the fluid in parallel. Now, if the Reynolds number is less than 2000, then the flow is said to be laminar. However, if the Reynolds number is more than 4000, then the flow is said to be turbulent. And the point at which laminar flow changes to turbulent flow, that point is known as critical velocity. So that's all in today's video. I hope you like the video. If you have any queries, any question, you can write in the comment section. See you in another video. Till then, stay safe, stay healthy. Thank you.